TSA Tech Talk on a sleepless night. HVAC humming low, everything's alright. Well, the real techs got our tools in hand. From residential to commercial, working across the land. Freon to compressors, we know the score. The do's and don'ts, the tips and tricks, and so much more. Hard work is honest work, it sets your spirit free. With the real techs, got our tools in hand.
And hey guys, welcome to the channel. We appreciate you tuning in. My name is Brent Lowry. I'm the TSA here at Ed Supply in Chattanooga, Tennessee. And on this week's episode, we're going to be talking about the ICP R454B unit, how to wire it up, and what are some of the side effects if you don't wire it up right, or if, because it is a little bit different. And in doing so, we're going to be also at some point using these. I know a lot of people, you see this and you go, I don't even know what that is. Oh yeah, that's right. We use it to prop up the furnace to level it out, but it's actually the install manual. And we're going to go over some of that and why they put the information there. So all this is intended to make us all better techs so that we understand why the systems are built and why that ICP designs it the way they do. As you've seen in the opening screen, I represent TempStar, Day and Night, which are ICP products, a division of Carrier. And usually your TempStar and Day and Night is the same as Heil and Arco Air and different ones. They're all really basically the same. They may have different names of some of the parts, but it's all basically the same design. Also represent Copeland, Fieldpiece, Navac, G-Connect, Hotpoint Hire, and our GE appliances. So quite a few of them that we kind of cover here at Ed Supply. And in part of this Tech Talk podcast or channel, if you will, because it's going on both platforms, we're going to bring you in with some hands-on, show you up close, and then take you along with us on some of our service calls. So the last year I was a service tech, 2018, and I had 1,150 service calls my last year. And then as a TSA, the last 3 years with that, and I think the last 2 years we've actually kept track of in-field service calls, and we're looking at like 259 service calls out in the field. So seen quite a bit over the years, and then especially with the new equipment that's coming out, the new Freon, that frustrates a lot of people because they don't understand the Freon. They don't understand what it is, what it's made out of, or why we're here. And I get that phone call quite a bit, probably on a daily basis or every other day, about why do they have to make things so difficult? Well, why do we have to do it this way? Why can't they just stick with the old Freon and the way they used to do things? It was simpler then. Well, in all honesty, once you understand the equipment, it's just as simple now as it was then. You're not going to hear terms like beer can cold anymore because you just don't use the feel of the Freon to know that you're right. Now, since then, and you look at that, and I hear a lot of people say that, well, I've been doing it 30 years or I've been doing it 40 years. This is my 30th year. And what does that mean? Absolutely nothing. Because I'm not putting in the same piece of equipment I did 30 years ago. The compressors have changed. The blower motors have changed. The Freons have changed. The metering devices have changed. The control boards have changed. The sensors have changed. All these things have changed since then. And in the last 2 years, we went from a 14 SEER up to 15 SEER. So the SEER ratings are changed. The way they test it are changing. And also, then you got ASHRAE got involved and started changing our friction rate for flex We'll explain some of that too and kind of show you how that lays out. But one of the biggest thing that has really changed is the way you install these units, and we'll go over that in certain podcasts and shows here on the channel, and kind of we'll keep you informed of what's coming up. But on this one, we wanted to focus on the ICP air handler, which is a FHM5X, and I think the one we're actually looking at is an 18. It's one I've got here in stock in the warehouse, and we've got it kind of hooked up to kind of show you up close, and then we'll talk about that, how to actually wire that up, and then we'll show you that video. Then we'll come back and we'll go over the manual with it so that you understand exactly how to wire it up and why that is. And then we'll kind of go from there. So we appreciate you tuning in, and stay tuned. We're going to show you out in the warehouse right now on the equipment hands-on. Most common things we run into is how do you properly wire up this air handler. So with ICP, and just to kind of explain a few things with ICP, is they have every one of these big labels on a piece of equipment and on the wires. We're going to go over exactly what label that is and where that wire goes, and then we'll kind of show you exactly how to wire it up so that you don't have any issues. Because one of the most common problems we have is this wire here, which is labeled Y out to fan coil, and a lot of people are taking this and they're cutting this wire because the old air handler had a pigtail that came out of this cap and had a white wire, and you would wire that to your white terminal on your thermostat. Well, you don't have to do none of that on this model, so that's why we're kind of going to go through this and show you this. So I'm going to get a closer up view of what we have here in just a second, and then we're going to go through this one wire at a time. So what I've done is I've taken my wire from my condensing unit, and I just put some black electrical tape on it so you could actually see and know this is a condensing unit thermostat wire. This is the actual wire from the thermostat. Alright, so we got our red wire. Then you have your red wire here, red R to thermostat. So we're going to tie these together. Alright, and then next we're going to go with our common. And most people, the ICP on this one is using brown this year. So we got brown on the common, and so I'm going to take and use my brown on my thermostat wires. A lot of the people use the blue. It's kind of, you can use either one. I mean, as long as you know which one it is. You could use black if you wanted to use black, but we're just using for this video and this example. I usually use brown just because that's what they're using, and that way I can keep everything straight. So. Alright, so we got our red and we got our brown. Now we're going to go with our white wire. This is my thermostat. So this one says, like we showed a while ago, white out to fan coil. You don't do anything to it. It's already hooked to the fan coil. So you can actually keep from getting confused. Tuck that one away out of the way. And this one here says white into thermostat. So I'm going to take the white and I'm going to tie it here. Now, the other thing too is your condensing unit has a white. There's nothing in these wires that say out to condensing unit. So you're going to take your white wire from your condensing unit, and you're going to go just like you always did, and you're going to tie those two whites together going into the thermostat. Okay? So our whites are done. Now we're going to come up to our green, and this is G into thermostat. And we've got our unit wired up, and we are now going to give it a call to come on. Now you can see in the idle position, which means there's no call coming into it. You see the amber light is on solid. So now we're going to give it a call for cooling, and we've moved this other way where you can actually see the condensing unit, because I want you to hear how quiet this system runs. And then we're going to talk about some other things here in just a second. Now, condensing unit's on. Now the blower motor comes on. So we've already hooked it up, went through its cycle, and you can always go through. There's part of this. Most of the issues I run into is the fact that it's usually a wire that's loose or something not wired up, and that's where your issue's at. Now, what I want to do is I want to kind of cover real quick the problems that we run into that we actually see going on in the field. And those problems are if the amber light is on and the blower motor is not running, then it's waiting on a call to come on. If the amber light is on and the blower motor's running, but you don't have a call for AC to come on, then it is sensing there's a leak somewhere, or there's something that's not right with the system. So then you have to look, and you can pull your speed tap wire here off, and if the blower motor stops, that's where the call's coming in. These, and I'll demonstrate that here in just a second. These new 454B units and this new control board, these motors are wired up with their 208, 230 at all times, and in the 24 volt is your switch. So when it sees 24 volts, it's going to come on. Now we're in cool mode on this, so we're going to have power 24 volts coming on this blue wire. If we were in heat, power would be coming on the white wire. Now, here's what I want to do. We're in cool mode, and here's something that every installer should do before they leave the job site, is there's a test button. Hold it in 1001, 1002. It's going to go into test mode. It instantly shuts this off, which what it does is simulate and there's a leak. And this unit comes off, blower motor's running, it's dispersing any refrigerant from the leak. You see the flash, that one flash means it is in dissipation mode. So this will go through a test for 60 seconds. And at the end of 60 seconds, everything will shut off. It'll go right back into cool mode and pick up and carry on again. That's how you know everything's working right. So let's see what it does. Alright. Amber light went solid. So it's out of dissipation mode. Test is over. Unit still hadn't kicked on yet. So now you may be going through a time delay. So still, don't panic. Let it run through its course. Be patient with it. Because all these, they've added in some timers. So this thing's going to run a few minutes. Then you'll be on your delay with your compressor delay 3 to 5 minutes, sometimes 8, depending on what thermostat you have. So wait about that long, and the condenser unit should kick right back on, just like it should, because we're still getting a call for cool. So real quick, while we're waiting for the condenser unit to come on, we're going to go over real quick what the wiring diagram is. You have a yellow in to thermostat. So your solid yellow goes straight to the thermostat wire. Your green is G in to the thermostat. It goes to the thermostat only. Your reversing valve, it goes straight to the outdoor unit. You have your yellow for the outdoor unit is attached to yellow with purple. And then your white wire, both of them, from the condenser unit and the thermostat, will go to the white here that is labeled white in to thermostat. So your condenser unit and your thermostat will go to this wire here. You do not have to worry about this other yellow wire like you normally would. That's where you would tap into with your thermostat. Do not cut those wires. If it has a factory connection on it, it's made to stay connected, not cut. So keep that in mind. So that's usually what we see in the field, is that either the common wire is not tied in, either this is tied in or broken with a float switch, or we see where the green wire is tapped into the condensing unit, or we'll see where they've cut this white wire here to tap in to the air handler or the heat strips or whichever way. But those are issues that I see. The other thing I see is if you have a bad board for whatever reason, maybe you shorted the board out, and that happens too, or maybe it's just a bad board out of the box, that happens as well. You'll see the light not come on and the blower motor stay running. Sometimes that is a sign of a bad board. Then I've seen it where if you go through the test cycle and then it comes back and it's flashing a code, you could have a bad sensor. So that's why when we install these, we always want to make sure we got it wired up right, and then we're going to go through the test process, and we're going to do testing cooling, and then it's going to come back, and at the end we'll make sure the condenser unit comes on, and then you go through a heat cycle, test it in the heat cycle, make sure it comes back on, and your heat kicks on like it's supposed to. And then we're going to talk about airflow. Why is airflow so important on the 454B unit? It's because of the dissipation process. If there is a leak, how they dissipate this refrigerant to keep any flames or sparks or anything possibly from happening is you introduce an oversaturation of oxygen, which means basically we're going to blow all this refrigerant up through the ductwork and out through the home. Now it's odorless, so you can tell your homeowners you're not going to smell a leak. It's all odorless, and it's not harmful because it's the same thing. Now you see our timer went out and our condenser unit kicked on, so it's back in AC mode. Now, so you can hear how quiet it is. These units are made to be that quiet. If you hear louder noises, or you hear strain, or you hear any kind of rattling, rattling's not normal. There was some compressors that when it shut off it would make a rattling sound, and that was because Copeland took the check-off valve or check valve out of the top of the compressors, and I think they went back and cured that on these new ones. But there's a lot of things that we'll talk about in future videos, but the main thing is how to wire this up and make sure you have it wired up and be successful. Now, we'll have some more videos posted soon, so we hope that helps you and hope that answers some of your questions. And as you can see how easy it is to wire up that new unit when you just take it slow, take it one wire at a time. And one thing about ICP, that when you begin to use the products and begin to look at how they're actually set up, they come from the factory. And if you look at the wiring, if the wire is bare, that means it's made for a wire nut, something you're going to twist on with a wire nut. If it comes back with a C claw or crab claw terminal on it, that means it goes under a screw on the screw terminal where the thermostats are. And if it has already crimped, that means you don't touch it. It's already done from the factory. So understanding that, it's not having to redesign or re-engineer something. A lot of guys, especially a lot of old school guys, get out in the field and they've done something a certain way all these years, and they think, well, I'm going to have to cut and strip and splice. You don't have to do that on new equipment. It's already been done. It's already been engineered, and anytime you take something from the factory setting and change it, you become the engineer, and you do mess up the warranty on it as well. So some other things we want to look at, we're going to pull up the actual install manual on that unit, and we're going to kind of go over some of those things real quick on it. So let's get this pulled up. And as you can see right here, we're on the FMA or FHM5. That's the air handler that we looked at. So if you're looking at here, you have your thermostat here, you have that dissipation board, and this is the fan coil, right? So when you look at this, we all know R goes with R, which goes with R, and then your G out will tie into the gray. Some of your fan coils will, on ICP, the gray is usually the blower motor or the fan, so you tie those two together. And then on the dissipation board and the thermostat, you're getting just green to green. This one right here will probably already be from the factory. It's probably already factory done, but anyway, you'll kind of see that. And then W out kind of goes from the fan coil to the dissipation board. That's already done from the factory. And so then you're going to come into your white W1, and it goes from the dissipation board to the thermostat. And this is the straight air system. So then you'll have your common, which is brown. And a lot of people out in the field will use blue. instead of the brown, and that's fine. I mean, you can use, I use the brown just because it's what the manual says, and I'm just so used to that. I've always used brown. Not well. Sometimes I've used the blue, but you can on the some of the condensing units that ICP has, they actually use black as their common. So sometimes they'll use black on the outside, brown on the inside. Some of the other units will actually use blue. So you kind of use whatever color you want to, just keep it uniform all the way through. And the thing is, make it as easy for you as possible. Okay. So you'll look at these different layouts that you have, depending on what unit you're actually working with, and then you'll come in and you'll actually see the blower motor controls here, and you'll see these numbers quite a bit. This first one, this common, this C, that is a brown wire, and that's your common on your 24 volts. So what these new motors are is they have this wire here, the L and the N have constant hot power and a ground on this motor at all time, and it's waiting for a 24 volt call. So it's like a 24 volt call is the switch. So your blower motor is constantly got 208, 230 on it, and it's waiting for the 24 volt signal to come on. Now, when you're wiring up the thermostat, if you strip back the wire that doesn't have a bare wire end on it, the one that's crimped together from the factory, then you're going to cause that dissipation board to read something it's not used to reading, and either your blower motor won't come on or it'll run nonstop. And then you kind of say, hey, I don't know what's going on because I've wired it up like I always have. And like I said, it's a whole different product. So you're not going to wire this up like you always have. The other part of that, if you'll see right here, you got speed tap 1, 2, 3, 4, and 5. Now, 4 is always designated for the heat because 3 and 4 are the exact same speed and RPM. So you can put your blue wire on 3 and your white wire on 4, and they're both in high speed. Now, it'll come from the factory set in 2. And when we looked at the unit out there in the shop, it is a 1.5 tons, which means you put it in because you need 600 CFM. Now, just because you buy a unit right out of the box doesn't mean it's going to have 600 CFM. So you're going to have to be able to tell it what capacity you want it to run at. So the factory just tests these motors from the factory to see what kind of CFMs they blow to make sure everything's right, and they just leave it in speed tap 2. It's up to the installer to confirm you have, in this situation, 600 CFM, all in blowing 0.50 static pressure or less, delivering that 600 CFM. So that's the responsibility of the installer. Now, why on this particular unit is that important? Because of the leak sensor that you have to go through. And I'm going to move in, see if I can move down this just a little bit. This is one thing here that we will mention at some point in time. Make sure you look at this. This is what a lot of people are using, these run traps or a P-trap. You cannot, this is not a P-trap. This is what they call a U-trap or a J-trap. So you have to have this for everything to drain right properly and for the static pressure, because you don't want this drain just dripping. If you're working on any of the ICP equipment, and I'm sure other brands do the same thing, if the line is just dripping, you got an airflow problem, or you've got where the drain can't breathe. So understand that you want it to pee just a solid, steady stream of water. The more water coming out of that drain, the less humidity that's going to be trapped inside the house. So keep that in mind. But I want to work our way down. On this, you're going to see the sensor here is at the bottom. The Freon is heavier than air, so the lowest point in the unit is roughly where they're going to have this sensor, which is here in the vertical position. If you go to move it in horizontal, you may have to move it over to here. Or if you're moving it horizontal right, it'll probably stay where it's at. The other thing I want to show you real quick right here If you can see this on the drawing here, usually if you have a leak on the ICP evaporator coils because your airflow is off, it's going to pop that feeder tube right there. And I thought it was interesting how they put their sensor right here, right underneath where that most common leak and crack when your airflow is off is right here, and that goes right into the sensor. So that's just something I want to kind of point out there. Here's your code for your dissipation board. If it's solid, it's normal. When you cut it on, you'll hear that blower motor run about 15, 20, 30 seconds, and it'll stop. You'll have a solid line. The blower motor will stop waiting for a call. That is normal operation. That's what we want. Once you give it a test mode or it has a leak, you're going to sense that this part here, the sensor, has reached a 20% of the lower flammability limit in that unit. So you got to figure the air handler itself, where the coil is considered 100%. So that sensor has picked up that 20% out of that 100% space. There's a leak. Now here's why I was telling you the airflow is so important. There's a timer on this. When it senses a leak, it's going to blow, and that's in this manual. You'll have to see where it's at, and you'll see this right here. You have to have a required dissipation CFM. So if you have 7 pounds of refrigerant in it, you have to make sure you have at least the right amount of CFMs to discharge all that through the ductwork. So a lot of times, the other thing too, if you have your white wire or your yellow wire that is not wired up right, you may get a code right here of 7 or 8, and that lets you know your wires are wired up wrong. And that usually helps too. Again, here is the big U-trap. Make sure you're looking at this manual when you actually set your traps up. This is going to be something you're going to see in the manual here, is if I have 8 pounds of charge in my system, I have to make sure I have 122 square feet minimum for if there is a dissipation system or there is a leak, I've got enough room that it will not be flammable when it discharges. So here's where I wanted to get to, this chart right here. And we're going to talk about this in the next video. So I'm not going to spend a whole lot of time in it at all. But if you look right here on these numbers, comes from the factory. Now keep in mind, you need 600 CFM. So Speed Tap 2 comes from the factory. The only thing that has 600 CFM are the first 2 squares. Now this is where if you're hanging on the wall with no ductwork whatsoever, you would be right here. And if you have a 90 on the top of that, you're going to probably be right here. Anything else, most homes are right here in this market, between 8 and 9. So you can look, if you're losing a half a ton of air, and in this case here, half the capacity, 50% of the capacity is gone, the unit's going to run nonstop. So how do you get that? And for those people that are listen that can't see this, you can go into the YouTube page, actually see what we're talking about, and there'll be a link on the website for that. You don't just move the speed tap on the motor up and it automatically does this. You have to read these numbers in your duct that you have, and then you read what is there, and then you adjust the speed tap to confirm that speed tap, along with this, delivers this. And once that triangle of those 3 numbers are working, you'll have confirmed you have that amount of CFM. So that's really what I wanted to go over with on this segment. So we appreciate you tuning in. We hope this helps. And again, we're going to go in the next segment on static pressure at some point with the dual manometer. We'll actually show how that works and how you set that up. And we'll be using some equipment out in the shop. And then sometimes we'll be out in the field demonstrating this stuff as well. So hopefully that'll help you understand how to wire up these new units from the ICP standpoint of the FHMs. Now, they're going to wire up a little different from the package systems and the PG, the gas packs. So, I'll tell you along the way of things I see in the field from where ICP had some issues coming out of the factory, what I see in the field where techs are trying to install it and the issues they're having, and we'll cover all those as well. So, anyway, we appreciate you tuning in. Until next time, take care, and may God richly bless you.
TSA TikTok on a sleepless night. HVAC humming low, everything's alright. With the real techs, got our tools in hand. From residential to commercial, working across the land. Freon to compressors, we know the score. The do's and don'ts, the tips and tricks, and so much more. Hard work is honest work, it sets your spirit free. With the real techs, got our tools in hand. From residential to commercial,